I'll show how to code an environment using this sample environment, like using the sample MDP. So in this MDP, we have three states, right? S0, S1, and S2. These are the three states, and we have in every state. In state 1, we have two actions possible, A0 and A1. And in state 2, we have two actions, again A0 and A1. And in state 3 also, state S0 also, we have two actions. So in every state, we have two actions which are possible. And upon taking one action, the next state is shown, and the probability of going to that next stage is also shown here. All right. And what is the reward that you will get for these transitions is also shown here, right? So now we have to see how to translate this MDP diagram into environment code. Okay, so let me show you one sample code, which this is uploaded in along with the assignment. So let's see how this code is representing this MDP. So in this code, like we have given the first function, like this method called weighted choice. What exactly it is doing is, if you have, like as described, you need not worry about what is exactly in this code. It's just a way to sample from a given set of probability distribution. So for example, if you want to use this weighted choice function to sample from a fair die experiment, like you have a die experiment where there are 6 phases for the die, and you want to sample one of the phase such that the probability of landing in each phase is 1/6, let's say. So you just give one vector called the sample space vector, which tells all the possible outcomes, and another vector which tells you the probability of taking each of these values. Since we are saying with equal probabilities, we are saying every point in the sample space has probability 1/6. Now, if you want to generate one sample from this random experiment, you have to just use this weighted choice function which we have given above. So you have this weighted choice, and you give the sample space, which is this, and what is the probability of each of those outcomes. You just give, and if you just press enter, like if you just run this statement, you get one sample from this some probability distribution. So every time I sample, I will get a different value. Like I will get one of these 6 probability, one of the 6 outcomes, depending on the probability that we give. So for example, if you want to sample some other distribution, let's say you want to sample a environment, you want to sample just one of these 3 numbers, let's say 1, 2, 3, and let's say the probabilities are 0.9 and 0.05 and 0.05. Okay, so if I try to sample from these 3 values with these probabilities, so what do you think the typical outcome of this random experiment will be? So if I draw many times, what is the time high? What is the value that I see most likely? It's because this has probability of 0.9. So if I run it, it's most likely I'll see 1. But if I run it a lot of times, I might see some other values once in a while. So let's see whether I'll get that. Yeah, once we have seen 2. I don't know if you have noticed it. But let's say instead of 0.9, and just give 0.6, and let's say 0.35. then sometimes you will see state 2 also. Right? So you understood how to use this function, right? The weighted choice. You just give some possible outcomes and you just give the probabilities corresponding to that. You will get this value. You will get one of the sample from this distribution. Fine.
Yes.
So after that, now we'll use this weighted choice because let's say you are in some state S now S1 and you take action A naught. Then we have three possibilities, right? With point 2 you go here, with point 7 you go here, and with point 1 you go here. So if you want to sample, okay, if your condition on being in state S1 and take an action A naught, then what is the next state? If you want to sample that, then we can use that weighted choice. We can tell that, we can say that the sample outcomes are S1, S2, S naught, and we can give 0.2, 0.7, and 0.1 as the. So just if you want, we can just try that once. So weighted choice. So let's say the choices are S naught, S1, and S2. Okay. And we had some three probabilities, right? Like 0.1, let's say 0.7 and 0.2, let's say. Right. So if you like, this is the sample. This is the possible next states. If you are in state C, if you are in some state S1, I'm just taking an example. If you take action A naught, so there are three possible states, and there are three possible probabilities for them. I just wrote them. So it will pick you one next state for you. Okay. So this part is clear, right? So how you can sample the next state if you know the transition properties. Any doubt at this point? No, Chetan, maybe it's easier if you ask him because there are only few people you can ask directly.
Sir, for the probability space, isn't that given for the action space in a given state?
No, that is a policy, right? The policy tells you what action you have to take in a given state. So right now we are not talking about policy, right? We are only talking about environment.
Okay. Yes.
So environment, like P of what we are talking about here is P of S dash given S comma A. This is what we are talking here.
Okay. Yes.
Right?
Yes,
so
yes.
for a given state and action, you'll have some probabilities for each next state, right?
Yes.
So these are the possible S dashes, and these are the probabilities for that
Yes.
upon some action. And given that you are in some state S and A. So this is just a way to show how you can use this function. Okay.
Yes. Yes.
Okay. So now we'll see what are all the things. Like we are going to create a class called MDP, and we have a constructor for that MDP. So for defining an MDP, what are all the things we need to give? To specify an MDP, what are all things we need to tell?
Transition probabilities.
Yes, right. So like we should tell the states, the different actions that are possible, and the rewards for taking different actions in different states. And sometimes we can also tell what is the initial state to start with, to start the experiment. Initially, what is the initial state I should start with? If you don't have any such special initial state, you can just write it as none. Okay. So now to define this MDP, so we are going to specify what is called transition probabilities. So we are going to specify in this format, which is shown here. Sorry. So if you see, we have three states, right, in our MDP: S0, S1, and S2, right? So in S0, what we are going to create a dictionary, which is called transition probabilities, and the keys for that dictionary are S0, S1, and S2, three states. Okay, and for S0, the value is also another dictionary where you're inside S0, you're telling what are the actions that are possible at S0. Okay, so if you see at S0, A0 and A1 are possible, right?
Yes.
So that's why there are A0 and A1, and now this is S0 and this is A0. So this is conditioned on being in state S0 and taking action A0. That is probability of S given S dash given S comma A. Okay, that is what we are talking about here. Probability of that you are given that you are in state S0 and you are taking action A0. What are all the next possible states? S0 and S2. Okay, if you see, if you are in S0, and if you take action A0, what are all the possible next states? S0 and S2, right? So that is exactly being told here. If you are in some state S0 and if you take action A0, the next states possible are S0 and S2. And the probabilities of them is 0.5, 0.5. If you see here, it's 0.5, 0.5. Okay. So just like that, for every state, you tell, okay, if you are in state S1, what are all the actions that are possible? And if you take action A0, what are all the possible next states? And what are their probabilities? So like that, you create a dictionary like this. Okay. So this is a dictionary where keys are the states and the values are again another dictionary where in the inner dictionary the keys are the actions. Okay, and inside that there is another dictionary where the keys are the next states and the values are the probabilities corresponding to that state. Is this clear?
Yes.
So there are dictionary, like we have a recursive dictionary structure here. We have one dictionary where the keys are the states, and inside that there is another dictionary where the keys are the actions, and inside that there is another dictionary where the keys are the next state and the values are the probabilities. So if you specify this, then you are giving the whole transition diagram except the rewards, everything you are giving, right? So you have to specify the rewards now. So for specifying the rewards, there are multiple ways of specifying. Here what we are going to specify is expected RT plus 1. We are going to specify this thing. Expected RT plus 1 given S A S dash. Okay. So if you are in some state S and you took action A, and let's say you landed in S dash, what is the expected reward for this? Okay. So there are multiple ways of specifying. We could have specified like this also: expected RT plus 1 given S comma A. So you know how to calculate these different things, right? If you know from the MDP dynamics, you can calculate all these different versions. Like this also we could have specified if you want. But here we are specifying like this: expected RT plus 1 given your current state is S and the action you took is A, and the next state you landed up is S dash. In that case, what is the reward you get? Okay. So for example, if you are in state S1 and you took action A0 and you landed in state S0, you get plus 5 reward. Okay. And if you are in state S1, and for other things, maybe the reward is 0. This diagram. Anyway, we'll see that. So you can specify the rewards like this. Okay. If you are in some state S1 and you take action A0 and you land up in state S0, then you get +5. If you are in state S2, if you take action A1 and you land up in state S0, you get -1. Okay, you'll specify like this. I'm assuming for other things, they'll take it as 0. Okay. So this is how you have to specify the transition probabilities and the rewards. After that, look, these are the inputs for this constructor, this method. Okay. These are the arguments which we are passing to the constructor, and whether there is any special initial state or not. Like these three are the things which we are giving. So here they are mentioned, right? The reward for anything not determined or not mentioned here is 0, right? So only non-zero rewards we need to specify. Other things it will by default take as 0. Okay. Any doubts still here?
No, sir.
So after this, there are a couple of things we are doing. As like this method will get executed as soon as we create an object for this class, right? Instance for this class, right? So first thing we are doing is we are checking whether all the parameters given are consistent or not. For example, all like these probabilities should sum to 1, right? In the inner dictionary, probability should sum to 1, right? Otherwise, it's not a valid transition probabilities, right? Like if you see here, these two are summing to 1. If you see here, these three should sum to 1. Otherwise, if you give some other numbers, you should throw some error. So like those kind of consistency checks it is doing here. There is a method called self parameter consistency, which checks whether the transition probabilities are consistent and whether the rewards are consistent, etc. So if you want to understand that in detail, you can understand this. Like this is the like, but you need not exactly worry about this. You can use it as it is. But if you want, you can check, understand this also. Like here, what is happening is like if it is just checking whether the transition probabilities that we are given is a dictionary type or not, because we are expecting in a dictionary structure. So this is using assert statement to check whether the transition probability of for every state which we have given, whether it is a dictionary or not. If it is true, then it won't do anything. This is the statement, each instance of this statement is checking whether it's a dictionary or not. If it is true, it will not do anything. If it is false, it will just say the transition probabilities should be a dictionary, but you have given something else. It will just throw an error. So like that, we are checking some basic things. Like for example, we are asserting whether the nest states, like if you are in some state S0 and if you take some action, there should be some nest state which is there, right? That means the length of nest state should not be 0. There should be some state which you should go into. Like, and the sum of probabilities, whether they are summing to 1 or not. So it will just do some basic consistency checks. You need not worry about this function unless you are curious about how exactly you are checking these conditions. Okay, so that you can check if you are interested. And you have another so you have defined like a variable called transition props, and you are assigning whatever the transition props is to that, and then you are creating a rewards variable and storing all the rewards in that, and initial state and number of states. How can we calculate the number of states? From the transition probability dictionary, we can find the length of that dictionary. It will be equal to number of states, right? Because for every state we have one key. So it will give us the number of states. And we are also defining a function called reset. What it will do is, if you are in some state, if you call this method dot reset, your initial state will be randomly reset. You will be randomly put into a new. It will reset the game. Okay. So these are some methods which are defined here. So let's understand a couple of these methods. So here, let's say you want to get all the states that are there in our MDP. Okay. So first of all, we'll check this through some example. So let's say I want to create a new MDP like this. Let's say you have access to this class and you want to create a new MDP. So what you should do, you should just initialize two random variables. Sorry, initialize two variables, the transition probabilities and the rewards. So for this Markov chain, these are the transition probabilities. Like there are three states, and for every state, what are the possible actions, and for every action, what are the possible next states and their transition probabilities. So you just define one variable like this, and you just define one variable called the rewards. And to create an environment, you just need to create an instance for that class, right? So this is the class which was defined, and for that class, you have to just pass these two arguments while creating an instance. So we just created these two instances, and we are passing it, and this will create an environment. Now, let's say you want to understand how many states are there in this environment. Okay, so for that, we had a function, right? We had a method. So if you just type like this, you'll get what are all the states that are there in that MDP, right? So this is that first function, get all states. It will return a tuple, which is nothing but the keys of the transition probability variable, right? So the keys of the transition probability variable are nothing but your states. So when you just call this method, you are getting all the states, just like this, like environment get all states, you will get a tuple which has all the states. Then what is the next method that is available here? It is get all possible actions. So if you want to know in a given state, what are all actions that are possible? Okay. So for example, if you are in some state S1, what are all the actions that are possible? A0 and A1, right? So that you can get by simply typing env dot get possible actions of in which state you want to find. Tell me some state.
S1.
Yes, right. So it will give you the set of all possible actions that are valid in that state. Okay. So this is just that function. So it is returning a tuple, which is it is looking at the transition probabilities, this dictionary. In the dictionary, it is getting the value of the like dot get will give you the value corresponding to this key. Okay. So if you have just so do you want me to explain this line? How what is the notation here, or you are comfortable? So you want me to explain this line, or how exactly is the syntax, or is this fine? Are you able to hear me?
Yes.
So you want me to explain this line or is it fine?
The dot get will get the keys in that state dictionary.
Yeah, so let's check that. So you please feel free to talk and ask because I have asked you to attend, some of you to attend so that you'll ask some questions. Okay. So this is exactly the syntax, right? So till this we know, right? If we just do this much, we'll get the whole transition probabilities. In that, if
Dot.
I call this as some x, and then now we are asking x dot get off. Okay, so we have to give some state here, right? So this is our end transition probabilities, and if you're asking get of S naught, then it will give you all these things. Okay,
Yes.
and in that dictionary, we are asking only the keys. So if you don't write dot keys, you get the whole dictionary corresponding to this key. So this itself is a dictionary. In that, when you type get of this S naught, then you'll get the value for that key. So this is the whole value for that key. So this additional parameter is just telling if that key is not present in the dictionary, then what should I output? So right now there is only S naught, S1 and S2, right? So if I ask it to get the value corresponding to S3, then it is not a valid key, right? So if it is not a valid key, what should I output? That's what is being shown here. So you need not worry about that. So if I write 0 here, then it will give 0 for any invalid key. Okay, clear?
Yes.
So if it's a valid key, then it will give the dictionary. And we wanted what? Not the dictionary, right? We wanted the, if we call this as y, then we want the keys of this dictionary, right? So the keys of that dictionary will be your actions, because for this dictionary the keys are the actions, right? So that's what we were getting for this. All this we have done for getting what? Yeah, for getting all possible actions. Okay. So this is a method which will give all the possible actions. Now, if you want to check whether we have reached a terminal state or not, or whether a particular state is terminal or not, then we can check that like this. Is terminal is a method which is checking whether a state is a terminal state or not. And how can we check whether a state is terminal or not?
It will not transition to any other state.
So there should not be any action to be taken there. Like if you can think like there are no more actions left to be taken there. Like that's how this is checking. So it is checking what are all the possible actions in that state, and it is just thinking that there is no possible actions. Or you can also check if there are actions, all the possible next state should be the same state. That also you can check if you want, but here it is assuming that a terminal state is a state where there are no more actions to be taken. You will just remain in that state forever since you don't have any action also to take. So that's why it is just checking the possible actions in that state will be length 0 set. That means it's an empty set. Okay. So this is if you want to get the next states, if you are in some state S naught and you take an action A naught, what are all the possible next states? Okay. So for that, first of all, it is checking whether that is a valid action in this state. So that is this assert is doing, checking that whether that action is present in the possible actions of that state or not. Because if you look at this diagram, if I say I'm in state S1 and I take action A3, so there is no action A3, right? So if you want to know, first when you ask what are the possible next states, if I'm in some state S and take action A, it is first checking whether that action is in the possible next states of possible actions, allowed actions for that state or not. If it is true, then it will not do anything. If it is false, it will just print cannot do this action from that state. Okay. So if you want, you can just try this once. So if you try to ask what are all the next possible states, if I am in state S naught and take action A3. So this is not a valid action to take, right? So the assert is failing. Cannot do action A3 in state S naught. Okay. And if you take a valid action, then it will show you, okay, if you are in state S naught and if you take action A1, the possible next states are S2 and that is with probability 1, right? If you are in state S naught and if you take action A1, the possible next state is S2 with probability 1. So that is being given. Right? So this is okay. So it is just looking at the transition probability dictionary, and in that it is looking at the state and the action and giving you all that inner dictionary. It is giving this dictionary. So these are the next states, and if you want to get a transition probability, you can also check. If you are in some state S naught and if you take an action A naught, what is the probability of going to some state S2? It is just instead of giving the whole dictionary, it is just giving the value for the next state probability. Like here it was giving the all possible states and their probabilities, right? Instead of that, you can also get the transition probability for a specific state. If you are in state S naught and take action A naught, what is the probability that I will go to S2? It will give one particular number. And this is get dot, this is get reward. So the reward is if you are in some state, what is how did we define the reward? Using what? You remember? So like there are multiple ways of defining the giving the reward information, right? How are we giving here? You remember? We discussed at the beginning of this tutorial.
Expectation of R T plus 1 given S and F A.
Given S, A and S dash. So S, A and S dash. These are the three inputs for this function. And first of all, it will again doing some assertion that whether that action is a valid action in the current state or not. If it's invalid, it is just printing an error statement. You cannot do this. If it is a valid action, then it will pass this assertion and then it is just giving, it will looking at the rewards and giving From the rewards, it is going to that state and that particular action and that particular next state and giving you the reward that is possible. So as I said, you see, right, why this writing 0 is useful here, because just before I described, right, if there is no such if element present in your dictionary, if you're searching for some key which is not there, then it will give a 0, right? So that's why instead of writing the rewards for all the possible nested states, we are writing only with those things which are non-zero, because by default it will give 0 if it is not present in this list. For example, if I ask the reward, if you are in state S1 and if you take action A0 and if you go to state S2, what is the reward? That is not present here. So it means it will give a default value of 0. That is what is happening here. Till now it's clear.
Yes, sir.
So, and this is reset. So what should reset do? What should reset do? So wherever you are, it will bring you to the initial state. Okay. So let's say if you want to check your current state, there is a function called render, which is given here. Like render is just printing your current state. Okay, current state is some variable which we are maintaining, and here we'll just print the current state. So if you right now you want to know in which state you are, you just type env dot if you just type env.render, it just shows I'm currently at state S2, right? So now if I press reset, env.reset, then it will take me to some arbitrary state from there. Okay, it is taking me to S0 because I said that initial state is none, because I'm not defining any initial state. That is, it is taking to some arbitrary state. But if I define my initial state, if I want, I can define like this. My initial state is S1. Okay. So now, if I check where I'm currently at S0. See, because I'm currently at S0. But when I press env.reset, what should happen?
S1.
Env.reset. Okay, so what is happening? Yeah, this not here. While defining the environment, I should give that, right? Like this is the environment variable I created, right? Instance. So if I just change here, it will not affect me because it is the default parameter. We haven't created the object. We have to run this line first of all. We haven't even run that before. But the best way to do that is for each state, let's say S1 is your default state, initial state, then you have to specify that here. Okay. Now, just now we created this environment, right? So if I render, what state will I get now?
S1.
Yeah. So I get S1. And there is another thing called step. I'll show you what it is. But let's say I take action A1. Then I have moved into new state S1. So if I render, I'll show that I'm at S1. I'll show you this thing. Don't worry about this. But you understood what is reset, what is render, right? So render will give you the current state, and reset will reset you to the initial state if you specify an initial state. Otherwise, it will take you to some arbitrary state from your current state. You need not exactly worry about this code, but if you understand what is reset, that should be okay. If you are curious, you can read what exactly is this, because they are allowing us to specify the initial state in multiple ways. Either we can specify the initial state exactly, or we can say it's none, or we can also make it as a function. So you need not worry about the specific details, but it will, if you want the initial state, you just while defining the environment, you just give the initial state here. In addition to the transition probabilities rewards, you also give the initial state. That should be enough for you, right? So till here everyone is fine, right? Till reset we understood. Now we are defining another function, another method called step method. So this is the main method. So this is like you are at some state and you want to take an action. How to take? That is what is telling. So right now, let's say what is the place we are right now? Render. So right now we are at S1, and let's say you are at S1, and if you take action A naught, what can happen? If you take action A naught, what are the things that can happen?
It can go to any three
not-
straight.
Not any three states, right? Yeah, it can go to any three, like this, and this. Okay, so that's what. If you want to take an action, that's when you use the word function step. So right now we are at S1, currently at S1. Now let's say I want to take an action A naught. Then you call it env.step of A naught. Then it will give you the next state and the reward that you got for that, and whether you reach terminal state or not. And if anything else it wants to describe, it can be described here. Okay, so this is like you are taking an action A naught, and the environment is giving you the next state, the reward, and whether you reach terminal state or not, and any other description about the MDP or the state. Okay, so right now you are in state S1, right? Because, and if you take action A1, what you are taking action A1, then the environment is putting you a new state S2 and it is giving you reward 0 and false. So when will we get this +5 reward? When you are in state S1 and take action A0, and if you go to S0, you will get. So let's try to be in S1 just to see that. So if you reset, since we gave the initial state as S1, we will go to S1, right? So right now we are in state S1, right? And what action I should take to get some +5 reward? I should take A0, and not I'll not get +5 reward for every time I take A0. I'll get +5 only when I take A0, and then it will land in S0, right? So anyway, so let's try to take A0, right? I took A0, and luckily I landed in S0, and I got a reward of 5. And this is not a terminal state, so it's false, and that's all. So this is the main thing that step does. It will take you the action and give you the next state reward, and whether it's empty or whether it's the episode done or not, whether we reached a terminal state or not, and any other information that you want to tell. Okay, so I think if you look at this code, you can understand what is happening. But if you want, I can explain you some of these details. So possible states and probabilities. So when you want to take an action, what is that you have to first see? You have to first see which state you are in currently, right? So this is the current state, and we are using the get test states method, which we have discussed earlier. So you are currently in some you are in this state, and we are getting all the possible all the nest states that are possible when you are in this state and take this action. So first we are getting that, and then that will give the dictionary, right? What are all the possible nest states and their probabilities, and we are just converting the dictionary into two vectors, because we wanted to use the weighted choice method, which will give us the sample from the distribution, right? So is this clear or not? Should I explain anything here?
Yes,
Yes, for clear or explain?
clear. Only that zip. What is that zip? Will
So zip will create a vector, a tuple from dictionary items. Okay, so let's see that. So if I have a dictionary, let's say I have a dictionary like this. So this is my dictionary, and when I write zip of, I'll call this dic sample dictionary. When I write so, okay, so it's, if you try to zip them, it will create an object called zip object. If you want all the keys in one vector, if you want all the keys in one vector and all the values in another vector, what you can do is a comma b equal to zip of uh, so if you see here, so it is giving me a is this, and what is b? S1 comma 2, right? So just a moment. Can you hear me?
yes, sir.
Okay, so here we are discussing the zip, right? So here you get the nest states, and if you take the zip, so this will help you get the possible nest states into one vector. Like that, it was a dictionary, right? When you get the nest states, it will give a dictionary like this. Like if you are in some state S0, and if you take action A1, if you ask the get nest states, it will give you a dictionary like this, right? So if you want to sample according to this, you want S0 and S2 in one vector and 0 0.5, 0 0.5 in another vector. So it will help you get that. Okay. So you'll get all the possible states in one vector, and all the possible and their probabilities in another vector. So zip will help you to get this, get it like that. Okay. And so now we are just sampling the nested state using the weighted choice function which we discussed earlier. So we have all the possible states and their probabilities which we got from this, and we are finding the nested state, right? And we also want reward. So the reward also we know how to get, right? We had a get reward function which was giving you the reward. So the get reward function is looking at the current state, the action, and the nested state. Our reward was defined based on these three things, right? So we are just getting the sample reward, right? We are getting the expected reward further, and then we are just checking whether it's a terminal state or not, whether the nested state that we reached is a terminal state or not. So if it is terminal state, then we'll write it true here, because it will give a true. If this function is terminal or not, we'll give a result true if it's a terminal state, otherwise it will give false. So we are writing that, and then for the next iteration, we should move into a new state, right? Like this is the next state which we have to move. So that's why we are making the current state equal to next state. That is, we are moving into the next state. Okay. And after that, it is returning you what new state you have entered into, what reward you got, and whether the episode is done, etc. So this is the main step function, which is taking the action and giving you the next state reward and whether it is episode is over or not. Okay. So that's all. Like you just need to define a class which has all these properties, like all these functionalities. So you just you can define all that you have to do is define a transition probability vector, a dictionary which corresponds to your MDP, and you have to define the rewards properly in this particular form, and then you have to just create an environment for that MDP like this, and here you can give the transition probabilities, rewards, and if you have any initial state you can specify, and after that you can try this for some few examples. Okay, so you can reset the environment, you can take some step, you can check by using render, you can check which state you are in, all these things you can do. So this is about creating the environment, and so that's all is there for the first part. You have to just create an environment and test using some few initial states and see what is the next state and how we are progressing. Just you have to just define it correctly and just use test whether it is working according to what we wanted it using some test cases. So this is about the environment creation. Any doubts in this part?
No, sir.
Awesome.
Okay, so this is all is there in the first part. So you can give it a try, and if you want, you can include like right now there is no return in this, right? We have only reward. Yeah, the return only the agent cares about the return. Environment will just act like this. If you are in a given state and if you take an action, it will put you in a new state and give the immediate reward. Yeah, only the return will come in only when the agent is doing something. It is bothered about the return, so it will calculate the return and all that. Anyway, that's all for the environment code. So if you have no other doubts, we can wind up this session with this.
Yes.
Okay. Thanks, guys. Thanks for attending. Bye.
Thank